Hello, today we're going to talk about Chapter 3.3, Variables on Both Sides. We've been through two sections already, and we haven't seen a problem yet where there is a variable on both sides of the equation. So let me show you what that looks like. So in example 1, we have a situation like this where we have obviously an equation, and we do in fact have a variable on both sides. So let's walk through how we would solve that. One of my rules I try to live by when I'm solving equations with the variable on both sides is when I make my first move, when I move these variables, I always like, if possible, to keep that variable term positive. So I'm going to subtract 6x from both sides. So it's going to look like that. And then I'll write my new line and bring down the 3, bring down the equal sign. 8x minus 6x is 2x, bring down the minus 21. And since I've got the variable on one side, this is now a two-step equation, which we worked on in 3.1 and at the end of 3.2. I'm going to add 21 to both sides of this equation. And that's going to give me 24 equals 2x. And then I divide both sides by 2. And I get x equals 12. So that is the basis of this entire chapter, is combine like terms, another vocabulary we talked about yesterday and the day before. But this time I need to get the x's, these like terms, on the same side of the equation. Let's take a look at one more example. Very similar to example 1, they're just going to put some geometry into it. So let's say they give you this situation. These angles are called vertical angles, and I know that vertical angles are congruent, or they're equal. So I can set up this expression equal to this expression. Alright, and so it's going to look just like this. 5x minus 3 equals 2x plus 12. Alright, again, my rule is to, when I make my first move, if at all possible, try to keep that variable term positive. So this time I want to move the 2x to the left. So I do that by doing this. I then get 5x minus 2x is 3x, bring down my minus 3, bring down my equals, bring down my positive 12. Again, a two-step equation from here on out. Add 3 to both sides. And then I have 3x equals 15. I'm going to divide both sides by 3, and I'm going to get x equals 5. Now, with that x equals 5, if I wanted to finish this problem, I would plug 5 into each of those degrees, these angles. So if I plugged in 5 into this top angle, 5x minus 3, I get 5 times 5 is 25, and 25 minus 3 is 22 degrees. So if they ask me what the degree of these angles are, I could say it's 22 degrees. Hope this helps, and we will see you guys